Welcome to Blizzard Fire. We hope this video helps fire up your solution.
You start by preparing a consistent test case. Open your minimal Rust project and reproduce the audio glitch reliably. Note exact toolchain and channel and log the audio backend, sample rate, and buffer sizes. Run with Rust log equals info or trace and capture stdout/stdir. This helps identify driver or timing errors. Once done, remove unrelated code and confirm the bug still appears in the reduced example, so you can focus on the real cause without guessing. You now instrument the code. Add timestamps at callback entry and exit, and log buffer fill levels to detect underruns or blocking. Make sure audio callbacks avoid locks, allocations, and blocking, I/O. Move heavy work to worker threads and communicate via lock-free queues. Once you see patterns, swap backends and change sample rates to see if behavior shifts, which reveals driver versus logic issues. Make iterative changes and rerun the reduced test so you track what actually fixes the glitch. You implement the solution. Remove allocations from the audio callback, use a pre-allocated ring buffer, and elevate thread priority or use real-time scheduling where supported. Then validate by running long-duration tests and varied sample rates and loads to ensure stability. If the bug persists, make sure to collect full traces, reproduce on another machine, and bisect dependencies or roll back recent crate updates. One troubleshooting tip: if intermittent, run with reduced system services and isolated drivers to rule out external.
Thanks for watching. If you found this helpful, don't forget to like and subscribe.